I'm very, very excited to be here and to talk to you all about mutual TLS and traffic control and reach authorization policy with our sidecar. This is my house. Actually, 10 years ago, we decided to purchase a land and build a house from ground up. And because we were building a house on a budget, so I had to look up what are the roles involved in building a house like that. So obviously there's a lot of roles, and I'm building on a budget. So these people I have not only build my house, but also build a lot of other houses in the area, right? Because I don't have dedicated contractor, I don't have dedicated project manager, roofer. So in order for their communication to be secure, in order for us to observe their communications, they drag a sidecar with them. And imagine my house where it's built was packed with a bunch of sidecars with the workers coming in to come to build the house. So that's stuff I would love to talk to you all about today. My name is Lin Song. I come from Cary, North Carolina. If you don't know where it is, it's on the map somewhere between New York City and Florida in the east coast of the United States. I am a founding member of the Istio project. I used to work at IBM for a very long time. Right before I left IBM, I went to the corporate directory and I took a screenshot of how many patents I contribute to the IBM portfolio. I think it's 207. I wrote 2 books about Istio, and I'm also one of the newly elected CNCF TOC member. I'm also a CNCF ambassador. The problem we're going to talk about is microservices. When you have lots of microservices, how do you connect, secure, and observe the communications among microservices? Imagine those workers as they build my house. How do I know what's exactly going on within the communications? So let me ask you guys, how many of you heard service mesh and know what service mesh is? Awesome. And how many of you use a service mesh today in production? A few of you, awesome. So how many of you know what Istio is? A few of you. How many of you know what Linkerd is, service mesh? Great. And how many of you also know Cilium provides service mesh functionality? Great. Pretty much equal amount of hands. Thank you. So I think most of you know what service mesh is. In a nutshell, it's a programmable framework to help you connect, secure, and observe your microservices so you don't have to provide these functionality in your microservices. So you have a consistency among your microservices to connect, secure, and observe the communication. So as far as service mesh evolution, I went to CNCF landscape and took a screenshot. Istio and Linkerd both are the 2 graduated CNCF projects. Most of the service mesh projects using Envoy as the proxy, as the proxy to mediate the traffic, except Linkerd. For Istio, we have a lot of happy sidecar users. So certainly we have a lot of users who are not happy with sidecar, and we know that. We also have a lot of users who are absolutely happy with sidecar, and these are some of the testimony from our users. But we do know there's a lot of users who are not happy with sidecar, and this is what the next evolution of Istio we're trying to address. So I'm going to start talking about a couple of challenges we have with sidecars today. The first biggest thing is transparency. It requires the injection of the sidecar, which literally means the moment you add your services to the mesh, you have to restart your pod that's composed of your services. So every single time if there's an Envoy CVE, you have to restart your pod to pick up the CVE. So it's not very, very not very simple for operation. And then instance, a lot of time when you start your pod, because the fact your pod may have your own sidecar, it conflicts with the service mesh sidecar, and it have startup or shutdown sequence problems. And Kubernetes jobs sometimes are not working very well with sidecar, because when the job finish, what about the sidecar? You don't want the sidecar continue to be running. So these are a couple of challenges with sidecar. The other thing with sidecar is it's one sidecar regardless of what function you need, right? We talk about connect, secure, and observe. So you may just need secure, but you're paying for the whole cost of the sidecar. So it doesn't allow you to incrementally adapt a fraction of the proxy. I mean, when they talk about Envoy proxy being very powerful and also very complex in the previous session in this room. So that's exactly part of the issue. You can't incrementally adopt the sidecar proxy. The other challenges with sidecar is over-provision resources. We've saw a lot of users on Twitter talk about, look, the service mesh sidecar is eating like a third of my cloud resources or my service mesh resources. And we have a lot of users telling us we can't figure out how much resources we should allocate to the sidecars. So these are some of the challenges with sidecar. Now I'm going to turn your attention to Istio Ambient, which is the sidecar-less mode we recently announced in Istio. Actually, I shouldn't say recently. It's about 18 months ago, and we recently announced production ready with Quotient beta in the Istio project. So in September 7, 2022, this is when we announced Istio Ambient, a way to allow you to enroll your application in the service mesh without sidecars. And how many of you know Matt Klein, who Matt Klein is? All right, a couple of you. So if you know Envoy, if you're using Envoy proxy today, you probably know who Matt is. He's the founder of Envoy. And he actually agreed this is the right architecture from a service mesh perspective. And sidecar, unfortunately, has been a very, very complex implementation detail. And we wrote a blog, we launched Ambient, focused on 3 functionality and benefits for our user. Number 1 is simplify operation, because you no longer need to drag the sidecar with your application pod. Number 2 is reduce cost. The fact that you don't have to have sidecar, you can potentially share a proxy among applications within your namespace or within your particular node. Comes a huge cost reduction. And the third benefit is improved performance. So let me walk you through a little bit about the architecture of Ambient. How many of you know what Kubernetes node agent is? I would expect every one of you, right? How many of you know what kubeproxy is, right? Kubeproxy is a node agent, right? So essentially, it's an agent running on your Kubernetes node. So in Istio Ambient, we have a node agent called Zero Trust Tunnel that provides mutual TLS, cryptographic identity for your pod, and upgrades all the connections from pod to pod using mutual TLS, using the identity assigned, specific identity assigned to your pod, and upgrade that connection to HTTPS without you actually need to do anything within your application. So imagine that's a node proxy, so it's shared by the application pod on that node. How many of you know what gateway is, right? So I would expect more of you, right? If you ever need to expose your application outside of your Kubernetes cluster, typically you expose it through Gateway API, right? The ingress V2, typically called. So that's what gateway is. It's like an entry point into your cluster, entry point into your application, so that allows clients outside of your cluster access your application. So in Istio Ambient, we have a waypoint concept, which is built using Envoy proxy. Acts as a gateway for your application scope that you feel comfortable. So that scope could be your namespace, for instance. It could be your particular service. It could also be your multiple namespace. So you have your own dedicated waypoint proxy that handles layer 7 traffic control, layer 7 authorization policy for your application. So I want to quickly talk about this new architecture. Why are we slicing the two layers, right? We talk about the layer 4 is a node proxy provided by Zero Trust Tunnel, and layer 7 processing layer is provided by the waypoint proxy, which is using Envoy proxy. The reason the layer 4 is it's a node proxy is because the layer 4 functions are very, very simple. So we believe it can be shared proxy co-located on that particular node, while the layer 7 function tends to be a lot more complex, and it can do like traffic management, timeout, retry, HTTP routing, circuit breaking, traffic mirroring, fault injection, right? It can do layer 7 HTTP level of metrics. It can do like an authorization policy, depends on maybe on method, HTTP method can be, so it can be very, very complex. You have regex rule in your authorization policy. So that's when you don't want one tendency that uses a lot of layer 7 processing, impact the other tenants out there. So in that case, it's great you have your dedicated layer 7 processing proxy, while the secure overlay layer focus on very, very simple function, and it can be shared among all the other pods on the node. So we kind of talk about why the two-layer architecture. This is just some quote by Louis, is one of our Istio founders in the community, and he talked about uncontrolled layer 7 config in a multi-tenancy proxy is outage, right? So you don't want to see that happen. You don't want to see noise neighbor impact other tenants, and this is exactly why we have dedicated Envoy proxy. And Matt chimed in, and he kind of agreed with that. We actually put a lot of thoughts into design ambient for scale. So we started using Envoy as the layer 4 proxy. Then we decided Envoy configuration is just too complex. So this is a slide from Yuval, who is very active in the Envoy community. He talked about Envoy configuration is not meant for human. And this is one of the talk about how complex Envoy configuration is. So as a community, we tried very hard to stay away from Envoy for layer 4 processing. So we designed a new configuration protocol based on workload information. As you can see, you can read this, right, without reading manuals. It captures like workload information, whether the workload is in Istio Ambient, and whether you have any layer 4 policy associated with your workload. It results in much simplified configuration. And then the other thing we also decided to rewrite the Zero Trust Tunnel is using Rust, because Rust is very high performance. So we kind of choose Rust, and it has very rich library to handle async communication. Waypoint architecture, I think I kind of touched a little bit on that. It's mainly based on Envoy proxy, and we did a lot of study on how Waypoint is actually simplified compared with Sidecar. So this is a diagram just to show you from Sidecar to Waypoint, we actually simplify the configuration to like Waypoint is less than 1% configuration of Sidecar. I know a lot of people talk about how Istio and Sidecar are so complex, and we really try to design ambient from zero trust tunnel to Waypoint to be so much more simplified so you can actually understand and use it. Now, I want to talk about user experience briefly. To include your application into Istio Ambient, all you need to do is just label a namespace for Ambient. A lot of application requirements that we had with Sidecar has been eliminated. And we actually done a lot of cost analysis with Ambient. So for instance, we've done analysis with 100 services in GKE using Google Cloud price calculator. And what we find out is the moment you are using from the base, which is outside, you don't use any service mesh, to Sidecar, that's like 30% of increase. But if you're using the base to Ambient with just layer 4 functionality, which you get mutual TLS, simple authorization policy, there's no extra cost. And if you're adding layer 7 functionality processing for all the services, you're paying about 10-15% more, which is still much cheaper than Sidecar. We actually have one of our users in production running service mesh. This is a quote he gave on Istio's birthday a couple of weeks ago. He said, significantly simplify management and reduce the size of the Kubernetes cluster by 20%. Note, this is not the service mesh infrastructure cost. This is the entire Kubernetes cluster cost. Before he was running Sidecar to now he was running without Sidecar by 20%. So that's very, very significant. We've also done a couple of studies ourselves, and you can see, between the stages, between no mesh to Sidecar, Sidecar has been using way more resources, particularly on the RAM side, comparing with Ambient or no mesh or Ambient with layer 7 functionality. And this is the same test with a stacked view. Now, before I get into demo, I actually want to show another company, which I actually don't know what they do, but they published a cool study recently in June 6th about the comparison of CPU and memory between Istio, Sidecar, and Ambient. And you can see Ambient is using a lot less of CPU, and particularly on memory. And he made a comment of 8 replica is using 46% less of CPU and 175 less memory compared with Sidecar between our new Ambient without Sidecar. Now, I would like to get to a demo. Because of the Wi-Fi is not very good, I actually want to show you guys a live demo, but now I'm going to show you guys a recording because I was practicing the demo over lunch and the Wi-Fi speed wasn't fast enough. So what I'm doing is I'm actually install a Kubernetes cluster using K3D. By the way, this demo, I didn't change any of the speed. So how the demo shows is the actual speed when I recorded on a high-speed internet. So I'm creating a Kubernetes cluster using K3S on my laptop. And now I'm launching K9S. How many of you using K9S to view your Kubernetes cluster? Yes, my favorite. So you can see stuff coming up. I also installed Istio ambient mode, right? You can install Istio ambient mode very easily. Just say profile equals ambient. And now I'm also deploying a bunch of monitoring tools. One tool is called Prometheus, right? It's a graduated CNCF project. The other tool is a Kayali, which is a dashboard for Istio. Now I'm installing Kubernetes Gateway API, just a customer resource definition. Now I'm install a bunch of application. So how many of you have used the Bookinfo sample application? A few of you, right? Okay, very good. So as you can see, my application is up running. And by the way, there's no sidecar. I'm not even in the mesh at the moment. I just installed Istio. So now what I'm going to do next is, I go to Bookinfo. I can reach out to the Bookinfo. You can see it's round robin between version 1, version 2, version 3, which is the red star, black star, and no star. So this is a default Kubernetes behavior. When you don't have any traffic control, it's like 33% based on the number of replicas. So this is great if you don't care about traffic control, but if you do want to do rollout, you might want to have a little bit more control. Okay, so what we're going to do next is we're going to actually label the namespace to be inside of Istio ambient. So we're going to enroll the namespace while my sample application is running into ambient. Notice I don't need to restart anything, right? So all the samples are still there without sidecar. And we're going to generate some traffic. So now we're going to launch the dashboard of we installed it in the monitoring namespace. So this is the Kayali dashboard. It's an open source project contributed by the Red Hat team. Thank you. Now I'm going to enable traffic animation and also security because I want to see the mutual TLS badge. I want to see the secure traffic communication between my services, hopefully. So the traffic is going to come in. It's going to take maybe 30, 60 seconds for the graph to render because it has to have enough traffic to show up and render the graph. In the meanwhile, we're going to launch the Prometheus dashboard. So what we're going to do is we're going to come back to Kayali, and we can see traffic comes in, but it's still not showing like the security badges we would love to. So we're going to try to curate some of the TCP metrics by just label my namespace with ambient. Now I'm getting a layer 4 metrics of in-premises. And so you can see the connection policy is mutual TLS in this example. It's from source to review to destination to rating. So all these metrics you can hook up with your alert system. This is just very standard TCP metrics generated by Istio ambient and all without sidecar. Oh, look, the mutual TLS icon is showing up. Very, very cool now. So you can see I'm actually getting mutual TLS enabled, and I can see my source and destination principal on the right side. I can also see the TCP metrics detailed information there. So just by label my namespace into with ambient, now not only I'm getting metrics, I'm also getting graphics dashboard. And now I know what's composed of the Bookinfo. For those of you who don't understand what's made up of the Bookinfo, now you have the visibility of this sample application by just adding the namespace with that ambient label. All right. So the next thing we're going to try to do is we're going to try to do some layer 7 processing. Remember we talked about 2-layer architecture? So we just deploy a waypoint proxy for the namespace or a sample application is running. So this is going to deploy a Kubernetes service and Kubernetes pod called waypoint into that particular namespace. And this waypoint will handle any layer 7 processing for us. So now if we try to sorry, I think I forgot to highlight one thing. No worries. So after waypoint is deployed, we are also applying some of the layer 7 functionalities into my cluster. So let's try access the sample application. So you can see right now when we go from sleep to product page, we actually have an authorization policy to only allow get access, but not allow the delete access, right? So because of this authorization policy is in place, now from sleep try to access product page on delete, we can recognize this a delete call, not a get call, and we're going to allow for disallow with 405, which means method level not allowed. And if you look at the waypoint log, by the way, you will be able to see access denied. And the reason you can't see it right now, oh, actually you saw it right there. And the reason you can't see it easily is because I have that loop going on early on. So we're going to try to kill the loop just so we can easily see it in the log. So go back, you can see 403, delete RBAC access denied matched policy. So if you're trying to do access policy that's not allowed, the waypoint is going to enforce that policy for your application and not allow it. And notice this is the waypoint proxy. Proxy is for the entire namespace the sample application is deployed. So if I have 5 microservices or 10, it's using the same waypoint proxy. Okay, the next thing we're going to do is traffic control. So we're going to try to apply a simple HTTP route using the new gateway API. So we're going to say review version 1 has 90% of the traffic, and I'm rolling out review version 2 with 10% of the traffic. All right, so let's see it happens hopefully soon. Look, very, very few review version 2, right? You see a bunch of review version 1. I don't know if it's clearly 90%, but you can tell it's roughly about 90% of review version 1. So the traffic control is also in place. All right, there's one problem I want to fix. So from my application to permissions, that traffic is not secure. If you notice, right, from product page to permissions, that traffic from Kayali is not secure. So we want to fix that. The other thing we want to show you is you actually have layer 7 metrics now. So by just having the waypoint proxy, not only you get layer 4 metrics through the Zero Trust Tunnel, the waypoint also provide layer 7 metrics. Like in this example, you can get HTTP level of request total. All right. So the other thing we are going to do is we're going to try to drill in a little bit on the graph, and we're hoping to see some HTTP metrics. Oh, right here. Do you see it? HTTP requests per second. So you can actually see the successful rate on the HTTP level. So this is provided by the waypoint proxy. And now let's look at the TCP connection from premises to product page and try to fix that. And to fix that, it's actually really, really simple. The only thing we need to do is label the monitoring namespace, which is the namespace we deploy permissions with Istio ambient enabled. So with that, we're going to try enable ambient into that namespace, and that should be it. We should be able to get back to the dashboard and visualize the communication is secure with mutual TLS between premises and the application. Does anyone have any questions as this comes up? Go ahead.
I have a question related to performance overhead. Like we have so much mutual TLS connections working in the background, then what kind of overhead can we expect in performance? I mean,
Yeah,
it won't be much.
that's a great question. So what I'm going to do is, by the way, before I get to your question, you can see the mutual TLS icon now between premises and production page. So what I'm going to do is actually get out of the recording, and I want to show you the performance latency number we published. So if you search performance and scalability on Istio.io, actually it's in preliminary because we haven't published this yet. This is like a staging site. So you can see this is the data between no mesh, which is without any mesh, to ambient with zero trust tunnel. And this is with ambient with waypoint proxy. And this is with sidecar. And this test, the latency is in milliseconds. You can see the latency is very minor. And the test is performed with 1,000 service, 2,000 pod with 30K mesh write requests per second. So check it out for that. Any other questions, or I'm out of time?
We have time for another question, sure.
Is there any prerequisite for applications to work with mutual TLS?
Actually, this is the best part of ambient. We know there was a lot of problem just getting premises to work with mutual TLS with Sidecar was very, very hard. With ambient, a lot of application requirements are removed. There may be one or two if it's like a conflict with the port number zTunnel is using. But most of the requirements have been removed. Like you can use stateful set. You can, like Kubernetes jobs works, yeah, pretty much long. The other thing I want to quickly show you, Sidecar is here to stay. If you're comfortable with Sidecar, you can continue to use it. And this is my house. I just want to show. This is the final build of the house. Imagine without the Sidecar. Any other questions? Oh, I'm out of time.
Round of applause. Thank you very much, Lynn.